Okay, so we've described the characteristics of the regular parent sine function. Here are some things that describe transformations of the sine function. Okay, in the first place, half of the distance, half the vertical distance from the maximum to the minimum. So think of the maximum being a peak and the minimum being all the way down here. Find that distance, cut it in half. For a sine function and a cosine function, is called the amplitude of the function. Think of it as how high does it go, or how low does it go. Take from the high to the low and cut that in half. So graph each function and name the amplitude. Okay, here's negative 2 times the sine of function. That didn't make sense at all. Negative 2 times the sine of x. Okay, its sine starts at 0 and it ends at 0 at 2 pi. That's what we're learning, okay? It starts at 0, and when you get to the end, it ends at 0. Halfway across, when I get to pi or 180, it's also at 0. Now it starts by going up to a maximum and it ends by going up to a minimum. That's what the sine function looks like. But this one is negative 2 times the sine function. So the zeros stay where they are. I'm going to go backwards and fill in the rest of these, by the way. Just following the pattern. If that goes up, then this one's going to go down, and then 0, and then up at negative 3 pi over 2, and then back down at negative 2 pi. If I multiply everything times negative 2, the zeros stay where they are. This negative 1 becomes a positive 2. 0 times negative 2 is 0. 1 times negative 2 is negative 2. And so this gets kind of difficult to follow, right? Because this was the original. Okay, that's the original. But this is what I got going on. This is my actual function. Okay, and then this was the original, so let me connect them. And then this negative 1 becomes a positive 2. The 0 stays the same. The positive 1 becomes a negative 2, and the 0 stays the same. So here is my actual function. All right, I'm going to do a trick because the dotted line and the solid line may start to get a little weird and ugly. So here's what I'm going to do. I'm going to take my finished product and I'm going to fill it with a thicker line. That way you can't make a mistake. And of course this keeps going and that keeps going, right? What is the amplitude? Well, if I'm at negative 2 here, I go up to 0, that's 2, and I go up to positive 2, that total distance is 4, and the amplitude is half of that. So the amplitude is 2. It's a distance, so we never call it negative. Even though there's a negative 2 there, we never call it negative. But basically, if you cut this graph in half, it's not an asymptote, but if you cut it in half, it's the distance from the middle up or the middle down. That's what the amplitude is. The height of the wave. If this was about an actual wave in water, and that's the water level, it's the height of the wave. That's the amplitude. Okay? Times the cosine of x. Well, cosine doesn't start in the same place as sine. Cosine, as an x value, starts at 1, and then it goes to 0. And then it gets to negative 1. It starts at 1, it gets to 0, it goes to negative 1, and then you guys know how the pattern goes. So this is one cycle, or one period of the cosine function. Well, if I go backwards, that means it's going to be a 0 here, and then a negative 1 at negative pi, and then a 0, and then a positive 1 at 2 pi. We're back to a positive 1. So here's the rest of the original parent function, cosine of x. I think for a while, until you get a real good feel for these, you should use the unit circle and put your important 5 points and sketch as a starting place. Okay, 3 times the cosine of x. This one's not negative. The zeros times 3 is just going to be 0. 1 times 3 is going to be up here at 3. Negative 1 times 3 is going to be down here at negative 3. This negative 1 will also be negative 3. This positive 1 will be positive 3. This positive 1 will be positive 3. I go through the zeros and I hit my new maximums and minimums. And here is the graph of the cosine function times 3. And of course this keeps going, and this keeps going on and on and on, right? So just to make it very clear what's going on, I'll blue this thing up with my blue marker. And here's a graph of 3 times the cosine of x. Now, the question is, what's the amplitude? Well, I'm down here at negative 3, and I'm up here at positive 3. Doesn't that make a total vertical distance of 6? The amplitude is half of that. Hopefully, you guys are catching on to a pattern here, right? Okay. The horizontal distance on a number line in radians or degrees. The horizontal distance on a number line that it takes for a trigonometric function to complete one cycle. I've used this word a couple times already. That's called the period of the function. How long does it take me, like for example, to get from the top back up to the top? Or from a 0 to go up and down and get back to the 0? How long, how far horizontally on the number line does it take for that graph to go through one cycle? Okay, so here we go. I'm going to graph 2 times the sine of x. Well, I start at 0, and I'm starting to get pretty good at this, so I'm going to go to the end and I end at 0. There's a 0 in the middle, and sine usually starts by going up to 1 and then down to -1. There's a point where you guys will do this so many times that it'll become a pattern and you'll be really good at drawing that really quick. Do not connect these with straight lines. I'll get so mad if I see that. Anyway, this one goes up to 2, so the maximum goes up to 2 and the minimum goes down to -2. So we got to get our maximums and minimums to go far enough, and here we go. The graph of 2 times the sine of x looks like that. So I'm going to get my blue marker and I'm going to blue marker it up. There you go. Can't mistake it now. It's all blue markered. There is the graph. It's 2 cycles worth of 2 times the sine of x. Now, let's actually do a little math here. This starts right here. It started at 0, and it took all the way around here to get back to 0. So this is the actual period of the function. It's that horizontal distance. Well, let's look at what that is. It starts at 0, and it goes to 2 pi. And how do you find the distance on a number line? You subtract. So the period is 2 pi. Or, if I was dealing in degrees, it would be 360. Okay, the cosine of x. It starts at 1, goes down to 0, goes down to -1, goes up to 0, goes up to +1. We've already graphed the cosine function once today, yeah? Do not connect that in a V. Those are not straight lines. Okay, so this is down to -1, back up to 0, back up to +1. So here we go. Here is a graph of the cosine of x, and I don't have to do a second version of it because that's the actual graph. So I'll get out my blue marker, and I'm going to blue marker it up. So we see what we're getting into. This, of course, just keeps on going. This keeps on going, goes on forever. I started at 1, here at 0. I finished at 1. I got through this whole process. I'm back at 1, starting the process over again at 2 pi. We have the same period for the sine function that we do as the cosine function. Why? Because it takes 2 pi to get around the circle and then start repeating yourself, right? This repeats itself because this repeats itself. So I'm going to go down here and I'm going to say because it takes 2 pi radians to get around a circle, and start over. See, that and start over part is what kind of points it out. I start over, I do the exact same behavior, that's why it repeats itself and looks the same. All right, next page.